Good morning, students. Today we are going to start new topic number 14, biomolecules. Now first we are going to see introduction. Principal molecules of the living world are nothing but the biomolecules. That is, these biomolecules are non-living bodies which can give the life to living organism. Bodies of living organisms contain large number of different molecules which constitute their structure. They are also part of various physiological processes taking place in them. Primary structural materials of organisms are proteins and cellulose. By means of unique process of photosynthesis, plants produces carbohydrates. Plants utilize the minerals absorbed by their roots to produce proteins. Lipids are the main ingredient of vegetable oils and milk fats. Nucleic acids like RNA, DNA constitute the genetic material of organism. Now in this chapter we are going to study some aspect of three principal biomolecules, namely carbohydrates, proteins and nucleic acids. Now first we are going to see carbohydrates. First we are going to see definition of carbohydrates. Carbohydrates are polyhydroxyaldehydes or ketones or compounds which gives rise to such units on hydrolysis. That is, these carbohydrates are polyhydroxyaldehydes or ketones which on hydrolysis gives polyhydroxyaldehydes or ketones. Some carbohydrates like glucose, fructose are sweet in taste and they are called as sugars. Starch is the example of non-sugar. The most commonly used sugar is sucrose, which is obtained from sugarcane or sugar beet. The sugar present in milk is called as lactose. Greek word for sugar is saccharon. Hence carbohydrates are also called saccharides. Origin of the term carbohydrate lies in finding that molecular formula of many of them can be expressed as CxH2OY. That is, these are hydrates of carbon. For example, glucose. Now molecular formula of glucose is C6H12O6 or C6H2O 6 times. That is, in glucose there are 6 carbon atoms and 6 water molecules. Then second, sucrose. Molecular formula of sucrose is C12H22O11 or it is C12H2O11 times. Sucrose, there are 12 carbon atoms and 11 water molecules. The next example is starch. Molecular formula of starch is C6H10O5 n times. That is, these starch are polycarbohydrates. In starch there are n number of C6H10O5 units are present, or they are represented as C6H2O5 times n numbers. That is, in 1 unit of starch there are 6 carbon atoms and 5 H2O unit, that is water molecules. Now we are going to see classification of carbohydrates. Carbohydrates are classified into 3 broad groups in accordance with their behavior on hydrolysis. That is, this classification we are going to see on the basis of hydrolysis. Monosaccharides do not undergo further hydrolysis. They are simple sugar. Then second, oligosaccharides. Oligosaccharides on hydrolysis yields 2 to 10 units of monosaccharides, and accordingly they are further classified as disaccharides, trisaccharides and so on. Third, polysaccharides. Polysaccharides gives very large number of monosaccharide units on complete hydrolysis. That is, monosaccharides on hydrolysis gives only monosaccharides. That is, they do not further undergo hydrolysis. Oligosaccharides on hydrolysis gives 2 to 10 units of monosaccharides. And therefore they are further classified as disaccharides, trisaccharides, tetrasaccharides, and so on. Polysaccharides on hydrolysis gives number of units of monosaccharides. Now we are going to see the detailed classification of these carbohydrates. First class is monosaccharides. These monosaccharides do not hydrolyze into smaller units. For example, glucose, fructose, ribose. Then second, oligosaccharides. These oligosaccharides on hydrolysis yield 2 to 10 units of monosaccharides. And third is polysaccharides, which on hydrolysis gives large number of monosaccharide unit. For example, starch, cellulose. Now these oligosaccharides are further classified into following classes. First is disaccharides. These disaccharides yield 2 monosaccharides units on hydrolysis. For example, sucrose. Sucrose on hydrolysis gives 1 unit of glucose and 1 unit of fructose. Then second example is maltose. Maltose on hydrolysis gives 2 glucose units. And third is lactose, which on hydrolysis gives 1 glucose unit and 1 galactose unit. Now second, trisaccharides, which on hydrolysis gives 3 molecules of monosaccharide units. For example, raffinose. Raffinose on hydrolysis gives 1 molecule of glucose, 1 molecule of fructose and 1 molecule of galactose. Third, tetrasaccharides, which on hydrolysis gives 4 units of monosaccharides. For example, styrose. Styrose on hydrolysis gives 1 glucose unit, 1 fructose unit and 2 galactose unit. Now we are going to see nomenclature of monosaccharides. According to IUPAC system of nomenclature, general name of monosaccharide is glucose. Monosaccharides with one aldehydic group is called aldose, while that of one ketonic group is called ketoses. That is, monosaccharide which possesses aldehyde group are called as aldoses, and the monosaccharides which possesses ketonic group are called as ketoses. These names are further modified in accordance with the total number of carbon atoms in the monosaccharide. For example, in glucose there are 6 carbon atoms. Therefore, it is aldohexoses. That is, glucose with aldehyde functional group and 6 carbon atom. Therefore, it is aldohexoses. Now, second example, fructose. Fructose possesses 6 carbon atom and ketone functional group. Therefore, it is called as ketohexoses. Now, first we are going to see in detail glucose. Glucose occur in nature in free as well as in combined state. Glucose can be obtained from sucrose or starch by acid catalyzed hydrolysis. Now we are going to prepare glucose from sucrose. That is, preparation of glucose from sucrose. Now this sucrose is hydrolyzed by warming with dilute hydrochloric acid or sulfuric acid for about 2 hours. This hydrolysis converts sucrose into mixture of glucose and fructose. Glucose is separated from fructose by adding ethanol during cooling. Glucose, being almost insoluble in alcohol, crystallizes out first. The solution is filtered to obtain crystals of glucose. The reaction is given below. Sucrose, molecular formula of sucrose is C12H22O11. When sucrose undergo hydrolysis in acidic medium, that is in presence of dilute HCl or dilute H2SO4, and when this is heated for about 2 hours, then formation of glucose and fructose takes place. Molecular formula of glucose is C6H12O6 and that of fructose is C6H12O6. Now these glucose and fructose are stereoisomers of each other. They have same molecular formula, but the functional group present in glucose is aldehyde and functional group present in fructose is ketone. Now we are going to see preparation of glucose from starch. Commercial method for the preparation of glucose. Commercially, glucose is obtained by hydrolysis of starch by boiling it with dilute sulfuric acid at 393 Kelvin under 2 to 3 atmospheric pressure. Reaction is given below. Molecular formula of starch is C6H10O5 N times. Now this starch is polysaccharide which on hydrolysis gives number of units of monosaccharides. When starch is hydrolyzed, n numbers of water molecules are used. In presence of acidic medium at 393 Kelvin temperature under 2 to 3 atmospheric pressure gives n number of C6H12O6, that is glucose unit. That is starch when undergo hydrolysis gives infinite number of glucose unit. Now we are going to study the structural properties of glucose. Glucose has an aldohexose structure. That is, in glucose there are 6 carbon atoms and aldehyde functional group. Glucose molecule contains one aldehydic, that is formyl group, and the remaining 5 carbons carry one hydroxyl group each. The 6 carbon atoms in glucose form one straight chain. That is, all 6 carbon atoms in glucose are in a straight chain. This aldohexose structure of glucose was established on the basis of the following chemical properties. Now we are going to study all these chemical properties side by side. First, molecular formula of glucose was found to be C6H12O6 on the basis of its elemental composition and colligative properties. The 6 carbon in glucose molecule form a straight chain. Now this can be explained on the basis of following chemical reaction. Action of HI and heat on glucose, that is hydrogen iodide and heat. Glucose gives N-hexane on prolonged heating with HI, that is hydrogen iodide. Now following the structure of glucose, that is CHO, CHOH 4 times CH2OH. When it is heated in presence of HI for long time, then formation of N-hexane takes place. That is, glucose undergo reduction to give N-hexane. CH3, CH2 4 times CH3. From this reaction we can say that in glucose all 6 carbon atoms are in a straight chain. Now next reaction we are going to see action of hydroxylamine and hydrogen cyanide. Now we know that glucose molecule contains one carbonyl group, that is formyl group or CHO group. This was inferred from the observation that glucose forms oxime by reaction with hydroxylamine and gives cyanohydrin on reaction with hydrogen cyanide. Now here this glucose CHO, CHOH 4 times CH2OH, when it is treated with hydroxyamine, that is NH2OH, Then here formation of CH double bond and OH takes place. That is CHO group is converted into CH double bond and OH. That is here oxime of glucose is formed. CH double bond and OH, CHOH 4 times CH2OH. This is oxime of glucose. And when this glucose is treated with SCN, then here cyanohydrin addition product is obtained. Here this CHO group is converted into CHOH-CN group and cyanohydrin of glucose is obtained. Then we are going to see next reaction, oxidation of glucose using bromine water. Now here bromine water is a mild oxidizing agent or weak oxidizing agent. And when this glucose undergo oxidation with bromine water, the CHO group present in glucose undergo oxidation to give COOH group. That is CHO group undergo oxidation into carboxylic acid group to form gluconic acid. That is COOH, CHOH 4 times CH2OH. The carbonyl group present in glucose in the form of aldehyde. This was inferred from the observation that glucose gets oxidized to 6-carbon monocarboxylic acid called gluconic acid on reaction with bromine water, which is a mild oxidizing agent. Now next reaction we are going to see acetylation of glucose. Now we know that in glucose there are 5 hydroxyl group. Now this was inferred from the observation that when glucose reacts with acetic anhydride or acetyl chloride, it forms glucose pentaacetate. As glucose is a stable compound, it was further informed that the 5 hydroxyl groups are bonded to 5 different carbon atoms in glucose molecule. Now reaction is given below. Glucose, that is CHO, CHOH 4 times CH2OH, when it is treated with acetic anhydride, then here all the 5 hydroxy group present in group glucose undergo acetylation to form glucose pentaacetate. Now look here, CHO. Now here there are 4 hydroxy group, therefore this CHOH 4 times is converted into CHO C double bond O CH3 4 times, and this CH2OH is converted into CH2O CO CH3. That is glucose pentaacetate is formed with CH3COOH, that is acetic acid. From this we can say that there are 5 hydroxy group present in the glucose molecule, and all these 5 hydroxyl group present in glucose molecule are present on 5 different carbon atoms. Now next reaction we are going to see oxidation of glucose using dilute nitric acid. Now glucose contains one primary alcoholic group, that is CH2OH group. Now this was inferred from the following observation. Glucose and gluconic acid both on oxidation with dilute nitric acid gives the same dicarboxylic acid called saccharic acid. Now look here, this is CHO, CHOH 4 times CH2OH. This is glucose. When it undergo oxidation with dilute nitric acid, it is converted into saccharic acid. That is oxidation of both CHO group and primary alcohol group, that is CH2OH group, is carried out into COOH group. That is, we'll get here COOH, CHOH 4 times COOH. That is, both CHO group and primary alcohol group undergo oxidation to give carboxylic acid, and formation of saccharic acid takes place. Now this is gluconic acid. This gluconic acid is obtained when glucose undergo oxidation in presence of mild oxidizing agent like bromine water, that is COH, CHOH 4 times CH2OH. And when this gluconic acid undergo oxidation in presence of dilute nitric acid, then here this primary alcohol group is converted into carboxylic acid group. That is, here formation of saccharic acid takes place. From this evidence we can say that in glucose all 6 carbon atoms are in a straight chain. Then there is presence of a aldehyde group, that is CHO group, in the glucose molecule. In glucose there are 5 hydroxyl groups, and these hydroxyl groups are bonded to 5 carbon atoms separately. And glucose possesses primary alcohol group which on oxidation gives carboxylic group. That is, when glucose undergo oxidation in presence of dilute nitric acid gives saccharic acid. Thank you.